Hi all, I'd like to take this opportunity to welcome you to the 2022 edition of the AWS ANZ Summit Online, and in particular this session, Build Fast and Safe Using Compliant Application Patterns. My name is Hafiz Sadullah and I'm a Principal Technical Product Manager at AWS. And joining me today is my co-presenter Dina Dalayan Thirugnanasambandan, who is a Principal SA Software Development Engineer at AWS. Both Dina and I are based in Sydney. Now, before we get started, I just wanted to reiterate that this is a Level 400 technical session. As such, we do assume that you are comfortable with AWS developer tools such as Amazon Code Guru, AWS Code Pipeline, AWS Code Build, Amazon API Gateway, and AWS Lambda. Let's take a look at what we'll be covering in this session. We'll firstly take a look at the potential that cloud offers you as application builders while highlighting the responsibilities that come with this. We then review traditional application development and deployment practices that are still typical of many organizations today and call out the multiple points of friction that these present to developers. We then briefly explore modern and next-gen DevOps and how it seeks to improve on the developer experience. Dina will then demonstrate concrete approaches such as securing early in the development cycle and building in best practices and standards for application development. Finally, we'll explore how you can cascade these scalable mechanisms efficiently throughout your respective organizations and drive adoption. During the second half of this session, we'll answer your questions and dive deeper into specific areas as needed. A challenge all developers face with cloud technologies is harmonizing newfound development freedoms and opportunities with building applications that are safe and secure. Meet Joe. Joe's an application development lead for any company. Joe's looking to tap into the benefits of the cloud for an improved development experience. Joe's looking to AWS for its promise of velocity and ability to iterate rapidly on new business requirements and application features. She's also looking forward to AWS taking care of the undifferentiated heavy lifting and underlying infrastructure, allowing her and her team to focus on feature innovation and simply building delightful digital experiences for her customers. She's also excited that she could deploy applications globally in minutes onto infrastructure that will be automatically scaled in response to usage. She's glad she doesn't need to worry about reliability and resilience, as most of this is managed by AWS. Joe's looking forward to an efficient developer experience in the cloud, as she now has the ability to define both the business logic and her application's infrastructure within her code. Now, before Joe gets too excited, she realizes that by building applications in the cloud, a lot of the responsibility to ensure such applications are secure and compliant now lies with her and her team. The number of security and safety concerns and obligations continually changes with new regulatory requirements and evolving application structure and features. These considerations can quickly become overwhelming for development teams. Let's take a look at how many development teams are typically operating today. Although the typical application development and deployment workflow that has emerged from agile methodologies is continuous and iterative, certain stages of this present friction that can reduce engineering efficiency. For example, there is still a dependency on manual activities. As shown, the peer review stage includes manual activities such as code reviews and depends on the available capacity of other developers to drive these forwards. These reviews in turn can require many cycles of rework and further review. With other developers primarily conducting these peer reviews, the practice does not typically prioritize a focus on security and compliance. There's also a tension between the improved velocity promised by continuous integration and continuous delivery and security gates. Security reviews are still largely conducted by centralized security architecture and operations teams. These rely on manual, document-driven, and time-consuming processes such as assessment against a risk checklist, a set of compliance standards, or control frameworks. it can lead to high-touch engagement between application teams and central functions. And all this can be exacerbated in organizations with divisional structures or multiple lines of business, as AWS services usage can be permitted with subtle differences or specific provisions across the distributed application portfolio. Finally, unmitigated risks and gaps may progress into production environments as central IT's understanding of a specific application's context and operating environment is unlikely to be complete. The use of runtime operational monitoring and detective controls, again owned typically by centralized security operations teams, means Joe is often pulled in to address security issues late in the cycle. This can result in a bit of a scramble by application development teams to address high-severity issues in a reactionary manner. This can impact productivity and lead to an unpleasant developer experience. So it's evident that the typical development workflow is not fully aligned to achieving the most effective security posture for applications. It doesn't consider well-architected requirements. Continuous integration and continuous delivery do not necessarily equate to continuous security, and it can still allow gaps between risk mitigation methods and detective controls and tools to arise. It's also important to clarify the roles and responsibilities of developers and security teams and understand collaborative accountability in order to improve trust. So how can we enhance the development cycle to optimize engineering efficiency, delivery effectiveness, and productivity? Organizations have a business imperative to deliver high-quality software faster and more reliably in order to remain competitive. Previous methods cannot meet the needs of enterprises today. DevOps automation enables rapid, incremental software delivery and is increasingly indispensable for delivering and managing modern cloud-native applications. Despite the promise of DevOps, many organizations still struggle to implement it. The overhead of evaluating many different tools and integrating solutions into a secure, highly available and compliant toolchain can be significant. Also, many organizations lack the skills and resources to invest in building and operating their own DevOps toolchains. Next-gen DevOps is the shift towards more automation and more proactive mechanisms that enable teams to innovate faster and with greater confidence. Designed to augment developers' expertise with machine learning capabilities, Next-gen DevOps is a journey from manual processes with infrequent deployments and slow innovation cycles to rapid iteration cycles with continuous integration and continuous delivery, as well as automated alarming for monitoring production. Modern DevOps encompasses many facets, including infrastructure as code, continuous integration, continuous delivery, source artifact management, observability, resilience, and security. AWS offers a comprehensive portfolio of DevOps-related services that address these areas and are designed to work together to help customers of all sizes and maturity levels be successful in implementing DevOps on AWS. Now I'll hand over to Dina, who will demonstrate how Joe can leverage DevOps automation to drive preventative application security and resilience analysis early in the development cycle.
Thanks, Hafiz, for explaining the friction between DevOps and security. A recent Gartner report found that 80% of the business that failed to shift to a modern security approach will face both increased operating cost and a lower response to attack by 2023. Having highlighted that, let's take a look at an approach to help Joe better integrate and align application security and resilience considerations early in the development workflow, specifically during the peer review stage. We will leverage automation and execute preventative analysis to shorten the peer review cycle through microfeedback. So, what are microfeedback loops? Microfeedback loops are intentionally short, providing developers with ongoing feedback to take early remedial action and increasing efficiency through automated checks. The microfeedback approach will drive the majority of commonly encountered issues to be resolved before engaging a more involved peer review. This approach also provides confidence to the peer reviewer that fundamental security, compliance, and linting requirements have been validated. As part of this, common expectations of code standards and quality can be established while shifting governance to the left. Importantly for Jo, early feedback empowers her team to remediate and rectify issues upfront and at their own pace, reducing the pressure later on after the application has been deployed to production. We will now illustrate an architecture using AWS services to help Jo implement a microfeedback loop mechanism. Jo can leverage AWS developer tools to provide continuous real-time feedback upon each code commit into the source repository and supplement this with machine learning capabilities integrated into tools such as Amazon CodeGuru. With an appreciation of microfeedback loop architecture, let's take a look at how this is implemented in practice. In our demo, Jo and her team are working to develop an AWS Media Insights solution. As a development lead, Jo has started her development in a dev branch. Jo has created an initial CloudFormation template and Lambda functions to support the template. After she has developed the code, she will push it into the dev branch. Let's do a refresh. Once pushed it into the dev branch, she's going to raise a pull request. Let's update the commit message. Upon raising the pull request, GitHub webhook triggers a code build job. Jo would like her team to receive an early feedback on the security of application, and she has integrated with a handful of tools. Now, based upon the committed code type, Java or Python or CloudFormation template, this code build job dynamically runs the corresponding security tools and provides details on the security findings. Generally, this microfeedback loop takes a couple of minutes to complete. So the code build job triggered by Jo has run successfully and provided recommendation based on the security requirements of a particular application. Based on the security findings, Jo will be able to address the security issues early during development lifecycle. The pull request will also be updated with the findings and recommendations from the security checks run on the committed code. On clicking the details, the security check to Jo is redirected to the code build job. This enables peer reviewers and developers to get on the same page and understand the set of well-architected best practices that were added in the code. Now, Jo has leveraged industry-specific external tools to validate the code committed and provide feedback to developers to improve upon this. Let's see how Jo can leverage machine learning to provide intelligent recommendations to improve code quality by identifying an application's most expensive lines of code. Amazon CodeGuru is integrated with source code repository. Jo leverages Amazon CodeGuru, which is triggered for every incremental code committed. In this case, Jo has Python Lambda functions, which are being analyzed and provided with security recommendations that needs to be addressed. For every code committed to the repository, CodeGuru is triggered automatically. Committed Python code in Lambda functions are analyzed and recommendations are provided to Jo's team, suggesting a resilience optimization and security optimizations. As we have just seen, Amazon CodeGuru can help to augment the expertise of development teams by adding intelligence to development activities. Amazon DevOps Guru is another tool powered by machine learning that can help to improve operations of running applications. Of course, there are many other tools that can be integrated into security microfeedback toolchain depending upon the type of code or artifacts being evaluated. Only a sample of these are shown in this table. While microfeedback loops are far more efficient and productive than long manual peer review cycles, they still exercise resources during frequent checks on application changes. many of the basic security and resilience consideration can be built into the underlying application infrastructure itself. This helps to shift governance mechanism as far to the left as possible. According to the recent Gartner findings, software engineering teams that take part in creating standards that work best for them are 23% more effective than their counterparts. In most cases, standardization can help to reduce complexity, effort, and cost. Established standards also more broadly mitigate common risk. In this way, standards help to accelerate velocity while facilitating compliance with security and other organizational or regulatory requirements. Introducing best practice standards can help to reduce the friction in the peer and security review stages of development lifecycle. They can be extremely useful for developers to simplify their build and integration activities. The vetted patterns are concrete artifacts that incorporate standards such as security consideration and architecture best practices. Joe's team, as well as others in the organization, can confidently utilize these patterns as a basic scaffolding to bootstrap development of new applications. For example, a containerized application running on Amazon EKS is a pattern that many teams may be able to adopt for their specific use cases. Rather than relying entirely on central security, risk management, and compliance functions, Joe is now empowered to create patterns that incorporate well-architected best practices for developing business applications. Here, we can see how the microfeedback loops we have already demonstrated can also be leveraged for pattern feedback and validation. The microfeedback loops reference organizational security policies and compliance requirements to preemptively drive code alignment with runtime checks that will monitor applications after they have been deployed. After a new or a changed pattern is validated via microfeedback loops, the pattern is built and published as a CDK construct or service catalog product for later consumption. Now Joe, to maximize return on investment and improve overall value and impact to her organization, she needs to implement a mechanism for the pattern created by her team to be easily and widely adopted by other teams. Scalability can be achieved by enabling the pattern to be available to teams in other lines of business for consumption and evolution via federated model. As shown, Joe can establish a central catalog of patterns accessible by teams across organization. This will facilitate discoverability and help to drive adoption over time. Let's demonstrate an implementation of this architecture. In this demo, Joe will convert her Media Insights application into a pattern to provide scalability and reusability for wider consumption. She will leverage a pattern manager application to create a pattern. So, Joe requests Media Insights pattern creation using the pattern manager application. On a pattern creation request, the application creates a repo at the backend and triggers a code build job. The created repo to build the pattern, then the code build job to set up the necessary infrastructure. The complete infrastructure setup takes a couple of minutes to complete. Let's do a refresh and check whether the infra is built by the code build job. We can see that the code build job has run successfully. It is responsible for building a dedicated pipeline for Media Insights pattern and leverages a standard CloudFormation template to create the pattern. The pipeline created by the CloudFormation template consists of the following stages. Firstly, the source stage, then build stage, which builds the code committed. Then it stores the generated code in S3 along with the controls. After determining the version, it publishes into service catalog and then registers the version in Amazon DynamoDB with metadata containing the links. Joe will now leverage the code created earlier and microfeedback loop to validate the pattern. After she has committed the developed code, she will push it into the dev branch, and once pushed it into the dev branch, she's going to raise a pull request. Jo would like her team to receive early feedback on patent security. She has integrated with a handful of tools. Let's take a look into the code build job triggered as part of the pull request. The code build job, based upon the committed code type, it runs the corresponding security tools and provide details on the security findings. In this case, the tool uses CF and NAG validation. Generally, it takes a couple of minutes to get complete. The microfeedback loop is now complete. The feedback loop reported vulnerabilities that are acceptable. For the purpose of the demo, we will assume a role of a peer reviewer and approve the pull request. The merge approval triggers a patent builder pipeline to build, validate, and publish the patent. Let's check whether the pipeline has been triggered. Yes. This takes a couple of minutes. Let's do a refresh. First step are to build the code and run security tools again to capture the security findings in S3. We see the code build job has run successfully to build and validate the merged code. The generated artifacts are stored in S3. To be more specific, the evaluated controls are stored in S3 controls folder. Architecture image of the pattern and architecture artifacts are stored in image folder. The usage markdown are stored in usage folder. The generated CloudFormation template is stored in the templates folder. If the Jo used a CDK construct, then it is stored in AWS code artifact. Based on the version, the pattern is published into the service catalog. After publishing the pattern, next step is to register the pattern in DynamoDB table. Let's look at the pattern stored in the DynamoDB table. Let me do a refresh. Metadata information about the published pattern are stored in DynamoDB table. In this case, it is a CloudFormation template and has been added to the service catalog as a product. The version is incremented for every commit that is done. Now, how do we scale and make this pattern available to other business units? Let's have a look at the pattern catalog. Let me do a refresh. You can see the published pattern in the catalog contains the version, usage, and architecture information, and so on. The published service catalog product can be deployed into the application account using service catalog. Anyone in Jo's development team can clone the repo and start leveraging the pattern for development. Now Jo's team has published a pattern. Another application development team can start off developing a custom application by using this pattern as its foundation. Utilizing patterns enables consistency and coherence across well-architected requirements, preventative compliance analysis, and runtime security monitoring. One thing to note is that the use of patterns should not be mandated or enforced. There will be many cases where published pattern may simply not fit or will need to be customized or specialized for teams' peculiar needs. Putting everything together, we can see that Jo has been able to drive greater holistic coherence across preventative safety mechanism and other controls. She has been able to work on these mechanisms into a next-gen DevOps workflow by leveraging modern AWS developer tools and emerging technologies such as machine learning. Her team has not had to compromise on the benefits of cloud for development such as release cadence and velocity. thanks to microfeedback loops and vetted patterns. Hopefully, this has given you all insights into how such capabilities are implemented and operated in practice. Back to you, Hafiz.
Thanks, Dina. Demonstration of some very useful capabilities there. Now, it's important to appreciate that what Jo has achieved will continue to enhance value over the long term. She's established a framework for AWS application patterns to be developed, validated, and approved against her organization's security policies and risk posture in an automated, low-touch, and scalable manner. The catalog of patterns now in place can be both leveraged and evolved by other development teams. Now that's certainly impactful. Over time, the benefits of patterns as accelerants will be appreciated. Adoption and use will naturally become embedded. This will drive a flywheel. In other words, a virtuous cycle of growing, reusable, and compliant artifacts that increase compliance coverage throughout your organizations. This will empower you as developers to contribute towards establishing relevant security and architectural standards, and to do so in an autonomous manner. The outcome is an improved developer experience. The solution and capabilities established in this session can empower you to become bar raisers and force multipliers for well-architected, secure, and policy-compliant applications that give your businesses an edge in the AWS cloud. We encourage you to set the flywheel spinning in motion as soon as possible for your own respective organizations. Also, stay tuned for an upcoming AWS solution implementation later this year that will help you to quickly and conveniently deploy and set up many of the capabilities we've demonstrated today. You can stay tuned via the AWS Solutions Library. Finally, if you have the time, we recommend checking out Darren Boyd's Summit session on scaling security optimized for fast and secure delivery, as it provides a security operations perspective on patterns and how these form a key part of a scalable organizational security framework. And with that, we conclude our session for today. To continue your cloud journey, please use these training resources as shown. Dina and I would like to thank you again for attending this session, and we hope you gain some useful knowledge and insights that you can apply in your own organizations. Meanwhile, we really value your feedback to help us improve our sessions, so please share your ratings on our talk today. Thanks for watching.